The other day, I got a comment from one of my subscribers asking me to make a video for them on angle proofs. Okay, so here's an angle relationship proof. In this video, I'm going to give you two examples. We're going to go through both of them. We're going to start with a fairly easy one, then we'll make it a little bit more challenging where you have more statements and reasonings to go about to explain why what you're proving is true. Okay, so what is a proof? A proof is just basically if you were walking somebody through a problem, explain to them, well, we know this because of that. You can talk it through really easily often. Okay, I know talking math isn't always easy, but usually verbally, just communicating with somebody, this is why we do what we do here. You can explain it in words. Well, proofs are just taking those words and putting them down as statements and then giving reasons of why those words that you're saying are true and factual. That's all a proof is. So what we start with is our given. Angle 1 is congruent to angle 2. I'm going to state that right now. I'm going to say angle 1 is congruent to angle 2. Now, how do I know that with my reasoning for being able to make this claim? Well, I was told this. This was given to me. So all I have to write for my reason is given. So you're typically going to start with your given piece of information. Since we were given this knowledge, we don't look at those and know that for a fact. Nothing tells me that these lines are parallel. I can't confirm that 1 and 2 are the same unless someone tells me they're the same. So since this was given to us, we write it down. Our reason is we were told. Okay, now the reason we were told this is because if these two angles are the same, we can determine something about these two angles that helps us to confirm angle 1 and 3 are also the same. So what do we know about these two angles here? So we're given this information. We don't need to know that in order to know something about 2 and 3. If I make two lines intersecting like this angle here and this angle here are what we call vertical angles. This angle will always be congruent to its vertical angle, just like this angle will always be congruent to its vertical angle, the opposite angle across from it. So since we know that, that is a piece of math that we learned way back in probably 7th or 8th grade, we can confirm that those two angles, 2 and 3, angle 2 is congruent to angle 3. Why? How do I know that? Because vertical angles are congruent. This is something we were taught back in the day. Vertical angles are congruent. So, what are we looking at? Vertical angles. 2 and 3, they got to be congruent. That's why. This is the statement. Now, if 2 and 3 are congruent, and 1 and 2 are congruent, the transitive property says A equals B. If A equals B and B equals C, then A equals C. This is the transitive property. If A is equal to B, well, A is the same thing as B. So B equals C, well, B is the same thing as A. So I can put an A right there. A would equal C. That's the transitive property. So why is that useful? Because that's what's going to tell us that angle 1 is congruent to angle 3. So now our last and final statement, we need to prove angle 1 is congruent to angle 3. Angle 1 is congruent to angle 3. Why? Because of what we proved up here, we can now say angle 1 is the same as angle 2. Well, angle 2 is the same thing as angle 1, so we could replace that with an angle 1, showing that angle 1 is equal to angle 3. How? Transitive property. So again, we are given something, we use some background knowledge we already own and have, and then that allows us to make a statement or a claim that we know to be true. So we have now proven that angle 1 is congruent to angle 3, because if angle 1 is congruent to angle 2, which was given to us, 2 has to be congruent to angle 3 because they're vertical angles. And if these two are equal, I could just say, well, if angle 2 is the same as angle 1, I could just change angle 2 to angle 1. And meaning it's going to also be congruent to angle 3. Hopefully this makes sense. You're just breaking it down in two columns, statements and reasons as to why it's true. Give the statement, something you need to know in order to get to the final result. What's your reasoning for each individual statement you're making? That is a proof. Here's another problem for you. All right, in this proof, you're gonna have a few more statements and a few more reasons to explain why angle 1 is congruent to angle 3. So they look like they could be the same, but we can't just confirm that unless we have some information, right? So that's where our givens come into play. We are being told angle 1 and angle 2 are supplementary. We got to know what the word supplementary is, so we'll talk about that. Angle 2 and angle 3 are also supplementary. So this angle and this angle, supplementary angles. This angle and this angle are also supplementary angles. So let's start by giving the given. So what were we told? We were told angle 1 and 3, or excuse me, angle 1 and 2 are supplementary. Angle 1 and 2, supplementary. How do we know that? It was given to us. We also know that angle 2 and angle 3 are supplementary. Angle 2 and angle 3 are supplementary as well. That was also given. Okay, so we have two givens. We're going to start with those two pieces of information and we're going to work from there. So the next thing we need to talk about is what the heck is supplementary? Supplementary angles are two angles that add up to 180 degrees. A total of a half rotation like that would be 180 degrees. They make a straight line. So if I had 100 here, that means that this angle would have to be 80 to make a total of 180. That's what supplementary angles are. So what we need to do down here is use that information. We're going to say angle 1 plus angle 2. So if I were to add the two angles together, that's going to have to equal 180 degrees. How do we know that? That's the definition of supplementary angles. So what's the reason for saying this? Definition of supplementary angles. Okay? 1 and 2 are supplementary, so they add up to 180. 2 and 3 are supplementary, so what do those add up to? You guessed it, 180. We're going to say angle 2 plus angle 3 is also supplementary, so those add up to 180. Definition of supplementary is our reasoning for this. We were told back in the day supplementary angles are at 180 total, so let's get the sum of them, write it equal to 180. Let's get the sum, write it equal to 180. We're just setting up equations showing what we already know. We already know supplementary angles are 180 degrees total. Okay, so now what we're going to do is we're going to use substitution to replace. If this is equal to 180 and this is equal to 180, they're the same thing, meaning this is equal to this. Why? They both equal the same values, so this has to be the same as that. So what we're going to do is we're just going to substitute this information here, angle 2 plus angle 3, which is the same thing as 180. We're going to replace that 180 with this information. So I'm going to say angle 1 plus angle 2 is equal to, but instead of saying 180, because this is also equal to 180, I can just write this information down. Angle 2 plus angle 3. How did we determine that? We just substituted 180 out and put angle 2 plus angle 3 in, right there. Substitution. We've been doing that since the dawn of time. Okay, so we're replacing. I like to tell my kids substitution is just replacing something with something we already know. So we already know 180 is the same thing as this information, so we're just going to take it and substitute it in. We're going to replace it in. Replacing, substituting, meaning the same thing. Okay, so now, if you look here, angle 1 plus angle 2 equals angle 2 plus angle 3. What do both sides of the equation have in common? They both have an angle 2. So we're going to substitute that out. We're going to take angle 2 away, substitution, subtract it out. So remember back when we were solving equations, we'd be like minus angle 2, and then we could cancel. That's all we're doing. We're just canceling out the angle 2's because they're on both sides. If I take an angle 2 away from here, take an angle 2 away from there, you're removing the same thing on both sides of the equation, so it stays balanced and equal. So what we're going to now do is say angle 1 is equal to angle 3. We know this because of subtraction. We're subtracting the angle 2's from both sides. Subtraction. And then last but not least, if angle 1 is equal to angle 3, we know that angle 1 is congruent to angle 3. And how do we know that? Because of the definition of congruence. If two things are equal, they are congruent. Definition of congruence. So we've now made it to the final result of angle 1 being congruent to angle 3, which is what they wanted me to prove. We started by only knowing angle 1 and 2 were supplementary. These add up to 180, those add up to 180. Well, if this number stays the same, these also must be the same. How did we prove it? We were given some information. We used the definition of supplementary to show they have to equal 180 each. Then we took the 180 and replaced it with this information here, setting up an equation. We subtracted angle 2 from both sides, and it left me with angle 1 equal to angle 3. If two things are equal, they are also congruent. That is the definition of congruence. And you have now finished a two-way statement and reasoning proof for angle relationships. Hopefully this makes sense. Study hard and good luck on your upcoming test.